I'm going to be starting out with acid rain. What does that mean? Basically, just background information. This is the Earth's atmosphere taken from the side, basically from either a shuttle or the Apollo or something like that. You can actually see the atmosphere here, and it's a little bit misleading because the atmosphere is actually tiny. If you look at its diameter, at its as its width, 120 kilometers, compared it to the diameter of the Earth of 112,000 kilometers. It's tiny. To give you a good comparison, if you compared it, slow down, Mark. If you compared it to that orange, where the center, basically where the edible part would be the mantle, the pesticide layer on the outside would be approximate thickness of our atmosphere. It's very, very thin compared to the whole thing. We know about the stratosphere, which has the ozone. We talked about that. The troposphere is where the weather and the bad ozone is. I'll repeat. Oops, sorry. This is slow. When we're talking about acid rain, we need to talk about something called the pH. Most of you had chemistry last year. Let me go through it, however. The lower the pH, the more acidic it is. Pure water, where it's just been deionized, distilled 5 minutes ago, is at a pH of 7. If it's a day later, it's going to have a lower pH. Normal rainwater is about 5.6. Why? Because it combines with CO2. CO2 is what gives your drinks the carbonation, which makes it acidic. Just being out in the air makes it acidic. And normal water is somewhere between 5.6 and 6. Rain with pH less than 5.6 is considered to be acid rain. And back in the 2010, there were lots of times when there was rain with a pH of 4.3. So anything less than 5.6 is acid rain. Definitely at 4.3. If we look at the pH scale, just a reminder, hydrochloric acid. Have any of you thrown up? You know how it has a sharp taste. That's because it's acid. It's actually hydrochloric acid down there that helps you break down foods. Lemons, vinegar, apples, tomato juice all have a sharp taste. That's how the ancient Greeks defined the pH scale, as something that has a sharp taste. If it is able to make your skin slimy, like ammonia, drain cleaner, bleach, something like that, it is said to be basic, where it slimes your skin. There are two forms of acid rain, acid precipitation. One of them is wet, so it's known as acid rain, acid fog, sleet, cloud vapor, snow. All of those come down on moisture, whereas it can also come down dry, whereas on particles, where the particles become acidic. Now, the compounds that are responsible for the acidity are sulfur oxides and nitrogen oxides, NOx and SOx. And you will hear that in various places, where 2/3 of all the NOx and SOx that is out there is typically from coal-burning plants. Now, when I first started teaching this class 20 years ago, 60 to 65% of all electricity was from coal. We're down much, much lower, which means hopefully the acidity, well, I know the acidity is much less. We'll be seeing evidence of that at the very end of this slide presentation. And so when the gas pollutants, sulfur dioxide and nitrogen oxide, dissolve in rainwater, acids are formed. Either carbonic acid if it's CO2, sulfurous or sulfuric acid, nitrous or nitric acid, all of those that can do damage to basically the environment. And so if we look at it, the stuff coming up from the power plants, In other words, when they burn the fossil fuels, that is called the primary pollutant. It's the first thing that comes out of the vehicle, out of the polluter. When it combines with other things, either as photochemical smog or when it combines with water, it becomes a secondary pollutant. Here, the NOx and SOx combines with water, forms acidic precipitation, and damages things, either the vegetation directly or by damaging the soil. When it damages the soil, oftentimes it leaches. It pulls minerals out of the soil, and they leach down out of the availability of the vegetation. Or they may leach aluminum. And when the aluminum is toxic to many things, the aluminum ions. So the wet acid rain is when the acidic water, whether it start out as snow or rain or anything in between, comes down, melts, goes through the ground. And it has a whole bunch of different effects on plants and animals, which we will see. Dry, on the other hand, is when the acidity gets on particles. They land on something. They may just sit there for a while, but whenever, if, for example, the needle of the pine tree is moist, the acidity will go in at that location. Several years ago, I was at Yosemite Institute, and they were showing me these places on either the oak trees or on the needles of the pine tree where there were little yellow dots. And that was caused by the dry precipitation, the dry rain, the particles of material that was acidic that landed on it and basically damaged the leaves or the needles. Half of the acidity comes back through acid deposition, and they do damage to all kinds of different things, which we'll see. Sometimes in water, it will dissolve the nutrients so they are not available to the fish or vegetations, and or they may remove the minerals from the soil. Then when that water goes away, so do the nutrients. Sometimes it will cause materials like aluminum to be leached out, which is toxic to various things. This is just looking at it another way, where you can see the plant emitting the sulfur dioxide, goes up into the atmosphere, combines with the water, rains down. It reacts with the limestone and breaks it down. We'll see a picture of that in a few minutes. It combined with the calcium, the magnesium, the sulfate, the aluminum, and remove them. All of those can be harmful. Now, one of the things you will note here is that if you have an acidic lake, one of the things that you can do is you can add limestone. If you add limestone to that lake, it will neutralize some of the acidity. So that is one of the ways that you can counter the acidity of the lake or of the soil. Effects on the wildlife. Especially if they are young, they are more sensitive to the effects of the acidity. Fish, if a pH is 5, the fish will not hatch. Lower than that, the fish will die. There have been places in New England where there were lakes with no fish in it because of the pH of the acidic rain. Effects on wildlife, again, it stresses those and leads to lower body weight and size, either because of direct toxicity or removing the nutrients that they need, and or adding toxic things like aluminum ions. And this just shows you that at high pHs and low pH, a fish will die. The optimum for life is somewhere between 6.5 and 8.5. Although one of the things I do want you to notice there is that there are some fish, some animals that like different pHs. Some organisms are better at different pHs than other ones. So on trees, it doesn't usually kill them directly, but it damages their leaves, limits the nutrients, and or it adds aluminum, which can damage the tree. aluminum ions. This picture right here is of Mongolia and Germany. Well, Mongolia is downwind from the Chinese coal power plants. Germany, this one right here, is downwind from either the coal power plants in Germany, France, Netherlands, well, not Denmark anymore, but they damage the trees like that. This is what's happening in North Carolina. North Carolina is downwind from Chicago and South Bend, Indiana, both of which have huge amounts of either coal power plants or production of steel. When you produce steel, you take iron, you have to heat it up super hot using coal, but then you use coal material in it to make it into steel, both of which will release the acidity up into the air. This is a statue. The picture on the left is from 1908. The statue there was put up there in the 1600s. After 60 years, the acidity completely and totally destroyed it. Again, if your lake that you're around is too acidic, add limestone to it. It'll dissolve and will get rid of a lot of the acidity. Now, what I want you to look at here is, where is the acidity here? In this picture. Is it up in Oregon? Washington? No. This place right here, that's Chicago. Right in here is South Bend, Indiana. Like I said, coal power plants and or production of steel. In which direction does the wind flow? This direction. Why? Because up here is the 60 degrees north, and so the Coriolis effect comes down here and goes in this direction. Now let's see what happens in the upcoming years. Oh, it's continuing to getting worse. Why? Because even though the Clean Air Act was enacted in the 1970s, we're not getting in completely in place right now. If you look 88, 89, yay. Better, and fairly not so bad. Any questions?